we just went through recently what was lecture 16F, 16D. When we went through that, we said if you can get the slope and the point on the line, you can find the equation of the line. And it does it this way. And we're going to do the same thing. But we're going to start in a situation where instead of knowing the slope of the line, we know 2 points on the line. Our job will then be, number one, find the slope of the line. Number two will be pick one to be your slope. Sorry, my badness. Pick one of the points to use with your slope. You're going to have two options. 2 points were there to start with. My recommendation is not to always take the first one. Some teachers say that. They don't trust you to think or anything like that. I totally trust you to think. Look at the first, look at the second. Whichever one's going to be easier is the one you should use. Both points work. I'm not going to spend a lot of time on this video showing that both points work. It's true, I could do it for each one and we could all go, wow, golf clap and whatever, but no, that's not the big deal. Both points work because each one's going to work on the equation line. We will work on it in the final step to make sure that it works, but it doesn't matter which one you pick, so please do yourself a favor and pick the one that'll be easier for you to work with. If you can't pick something that's easier, then always go with the first one, and may God have mercy on your soul if the first one's awful and the second one's easy. So I'm going to say, try and pick the easy one. Get it done. We'll go from there. Find the slope of the line. There are 2 ways to do this. If you learned something from me about how to find the change in Y or the change in X with long trip, short trip, by all means do that. If you can't comprehend what's going on and you're like, I'll take my chances with the formula, go ahead and do that. If your chances work out, it'll work out, and if they don't, that's life with luck and so forth. But we got to find the slope of the line. I'll do it with long trip, short trip. You need to get the exact same slope if you use the formula as far as the sign and the finished reduced fraction that we've got for the slope. Number 2 is pick the easy point. This is real. Pick. You get to choose, and they both work. Now, I am going to use the number 1 here, but not because it means you must use the first one. It means we need numbers for these. So that's not going to be a 2, right? We want them from the same point. You can't say, the first one has a good X, the second one's got a good Y, let me use those. They have to come from the same point, so these have to be from one of the 2 points. Pick a point to use for yours for X1, Y1. Then you have the slope and you have the point. So then you're going to, number 3 is a bunch of steps, like that. Find the equation of the line using the 3 things that we used before. In order, the way that they get used in y equals mx plus b is the exact value of y from the point that you selected, the slope that you found by either the formula or understanding what you're doing and using long trip, short trip, and then finally the value of x sub 1. So those would be the ones that you'll use to go in there. So you do get to have a choice as to which of the 2 points you're going to use, and then you go with that one. Find y equals mx plus b, you're going to have your answer. Test both points in your equation. The 2 points that you started with. Now this is a check, so I'm going to put a little asterisk on it, not because it's hard, but if that works, your line has to be perfect. You don't have to wait for me to grade it or anything like that. If your y equals mx plus b works for the first point that was given to you and the second point that was given to you, one of them you used to get here, so really you only need to check the other point, then you know it's perfect. We'll do a couple of these. Find the equation of the line. Through these 2 points. And our first one is through 3, 1, and 6, 7, all in the first quadrant, no negatives. Let's give us no fractions are actually going to come out of this. I want you to watch the process of what goes on, see how we go through it, and then I'll hit you one with fractions so you can see how fractions can become a part of the tough work to get through it. But let's get our slope. So we've got 3, 1, and we've got 6, 7. And to get from 1 to 7, I have to stay, I'll show you the graph over here. Here's my 0. I'm going from 1 up to 7. That's a 6. Plus 6. 1 plus 6 takes me to 7. Now the other one is a 3 to 6. So I'm starting above the 0 at 3, also going up. It's going to 6. So to get from 3 to 6, I have to go with plus 3. I went short trip here, 7 minus 1 got me 6. Short trip here, 6 minus 3 got me 3. I already knew they were both going uphill, so my m is equal to 6 over 3, just 2 over 1, which equals 2. So now I'll come over here and I'll write up that m equals 2. Now, I got some other stuff here for you. I need m, I also need y to come before it, and I need x to come after it, like that, when I'm setting up what I'm doing for y equals mx plus b. I think I'll use this one, 3, 1. Here's how I make my decision. You can make yours differently, you can go with a different process, you can even come up with another one if you want to use 6, 7. But here's what I did. I don't want any fractions in there. If I can avoid fractions, I'll do it. Neither has fractions, I'm good. Maybe I want to avoid negatives. Neither has negatives, so it's still a tie. I go for the smaller numbers. Now we have calculators, so it's not as big a deal, but I used to say, all other things being equal, I'll go for the smaller numbers. This has a y value of 1 and an x value of 3. And I want to do y equals mx plus b. So I'm going to come through and get all the pieces that I want. The y that I found is a 1. Equals is equals, right? It's not flexible or variable in any way. M is 2. I need to multiply by, so I can't write it as something that you might see in another way, like 23 or 2 plus 3. It's going to be 2 times 3 plus b. And that's got me set up. Now that is y equals mx plus b, but I didn't know b. I knew numbers for everything else. I need to multiply 2 times 3. 1 equals 6 plus b. I need to get b alone, so I'm going to subtract 6 to get there, or add negative 6 to each side. 6 minus 1, they work against each other, gets me 5 negative. Strong negative like the 6. This is gone. B. Y equals slope x plus intercept. Well, I wrote the stuff that wasn't words. Y equals x plus, but the slope is on here somewhere. I had to work for it, but it was a 2. Plus b. B seems to be negative 5. Y equals 2x minus 5 is another way someone might do this. How do I check it? Well, what I would do is take the one, this one here, 3, 1. Let me put in a 3 for x. 3 for x. 2 times 3 is 6. 6 minus 5. 6 minus 5 is 1. That's what the y made. So that one works. That's definitely on the line. How about the other one? It's also supposed to work. If this one works, both x and y, both slope and my y-intercept are perfect. 6 going in for x. 2 times 6 is 12. 12 minus 5 is going to get me 7. And that landed on 7. It's perfect. No other slope, no other intercept would do it, but these are perfect because they work for both. So that's the process. You might want to look at this one a few times, slow it down, whatever, to get through it. Work through your homework ones that have no fractions, because now if you just rely on what's coming next, you're going to see the same stuff with fractions. So I'm going to get one for you with fractions. And the fractions could slow you down, but the process is the same. We do not change the process. When we compute with fractions, we can use a calculator to help cover up a weakness. Or we can work our way through the arithmetic and get better at fractions. You have a choice. Here we go. We're going through these 2 points. 3, negative 5. And negative 2, 1. Okay, so 3, negative 5, and negative 2, 1. So what happens is I've got to connect my y is on top, my x is on the bottom, I got to go from negative 5 through my 0 on up to 1. You can see I'm going up to 1, I set up already. But I'm starting at negative 5. 5 flights up to the ground, 1 more to get there. Went up the whole time, up 6. Negative 5 plus 6 gets me to 1. The other one, I'm going from 3 to negative 2. Here's my 3, ground floor, negative 2. 3 to negative 2, downward. 3 steps downward to get to the ground. 2 more to get to where I gotta be. That's negative 5. M equals 6 over negative 5. It might work a little bit better for me if I put the negative on the top and dealt with it that way. Might just be easier to get it squared away. So M equals negative 6 over 5. We're probably going to need to clear fractions in this. Maybe not, but probably. No fractions, no fractions. They're both okay now. 1 negative, they're both okay now. I'm going to go with this negative 2, 1 right here as the point that I choose to use. It doesn't have to be. You can use the other one, but I'm going to check it at the end. Anyway, so the y that one offers me is 1, and the x it offers me is negative 2. Y equals mx plus b. So y is 1, equals is equals. M's going in as negative 5. I gotta know mx is m times x. I'm gonna multiply it by negative 2 plus b. There's a fraction here. If you have a calculator that can do negative 6 fraction 5 times a negative 2, you can find out what that makes. It's okay, that's good to do. If you don't, well, then we've got to do what we work on. Right, we're going to put a 1 under this, and we're going to see that this is going to get me 1. 6 times 2 is a 12. 5 times 1 is a 5. Red and blue, 2 negative signs. It's the opposite of negative, that's positive, plus b. Now I'll write 1 over 1 with space behind it, 12 over 5 with space behind it, plus I'll put space in front of my b. I gotta clear that fraction. 5 is the only denominator I have to deal with, so I'm going to have to do LCD equals 5 over 1. And I do that. 5 over 1 here, 5 over 1 here. Multiply each term by 5 over 1. Canceling denominators. Black 5 divided by 5 is a 1. Blue 5 divided by 5 is a 1. The other 5 stay in place. 1 times 5 is 5. Equals 12 times 1 is 12. Plus 5 times b is 5b. Subtract the 12. Negative 7 equals not b, but 5b. Negative 7 equals 5b. Must divide by the 5, and I get this ugliness. b equals negative 7 over 5. So now I've got y equals slope, which I don't write, x plus intercept, which I don't write yet. I go back and I figure out, all right, where did I find in this problem the slope? I see it here, negative 6 over 5, a couple places. Found way back here, but there's the slope. X plus intercept. Intercept comes from 0 and the value of b, so I need the negative 7 over 5. Now you can use your calculator to check this. If I put in x, let's try this one. Negative 6 over 5 times negative 2 plus negative 7 over 5. You see what all that equals, and you hit equals, and it's going to come out as negative 2. If you do it with your own work, you're going to put a 1 in there, you get negative. Let's see, you're going to put in the negative 2, you're going to get 12 minus 7, gets you 5 over 5 makes 1. Boom, we hit that. So that one works. That's the one that we used. How about the other one? Does that work? X going in as a 3. Negative 6 over 5 times 3. That's negative 18 over 5 minus 7 more over 5. 18 plus 7 together make 25, strong on the negative. Negative 25 over 5 is going to get me negative 5. That's where that winds up. So that if you put a 3 in for x on your calculator, negative 6 fraction 5 times the 3 plus negative 7 fraction 5 equals, it should hit the negative 5, and you know it works perfectly. One more thing for you. What if we need this in ax plus by equals c form? We have 1y equals negative 6 over 5x, space behind the fraction, plus negative 7 over 5. And we'll say that the LCD equals 5 over 1, and we'll multiply all 3 places by 5 over 1. No canceling here, but the 5's cancel, the 5's cancel. And we get 5 times y equals negative 6 times 1 with x, negative 6x, plus negative 7 times 1, negative 7. Add 6x to both sides, and we got what we need. We got 6x plus 5y equals negative 7. 6x plus 5y equals negative 7. Put that in for x, 18. And then minus 25, you do hit the negative 7. Put that in for x, negative 12 plus 5, and you get negative 7. And this is ax plus by equals c form. Good.